Hi, so welcome to Hooked on Hooks. My name is Erin Zimmer. I work for a company called Atlassian. We make tools like Jira, Confluence, Loom, Bitbucket, all different tools to help your team work better together. This talk is very full of code examples. So if you want to have a look at them yourself, if you want to look at the slides yourself, they're available on hooks at hooks.ez.codes. And also, I guess you can get me on Twitter if anyone is still on Twitter at Erin J. Zimmer. Okay, so today we're going to talk about why hooks, the rules of hooks, and why they're so confusing. And we're going to have a look at the implementation of useRef, useState, useEffect, useMemo, and useCallback. All right, so let's start with that first question. Why hooks? Now, if you're anything like me, when you first learned how to use hooks, they probably seemed a little bit like witchcraft. It's not really obvious what's going on behind the scenes, and it's really hard to build like a mental model of what's going on, which might cause you to wonder, why even bother with hooks? The answer to that is that we need hooks because we like to write functional components. So if you're newer to React, you might not be aware that there are actually two ways to write components. You can write a function, the way that we usually do it these days, or you can write a class. The class needs to extend the React.component class, and it needs to have a method called render. These days, we usually write functional components, and there's a few reasons for that. I mean, first of all, obviously they look cooler, but also functional components are pure functions. So that means if you put the same props in, you're always going to get the same HTML out, which makes them a little bit easier to reason about. Functional components don't have lifecycle methods. So if you're writing a class-based component, as well as the render method, it could also potentially have a bunch of other methods, and they're all called things like component did render, component will render, component thought about rendering, and then decided not to render. I don't know, there's a whole bunch of them. I can't remember what they're called because I don't write class-based components anymore, and I needed to use all of that brain space to store trivia about June for the new movie. So, yep, lifecycle methods. Thirdly, functional components have less boilerplate. Because of the way that the this keyword works in JavaScript, if you're writing classes where you need to pass around callbacks, you need to write a whole bunch of boilerplate code, and it's very boring. And finally, the React team claims that functional components are easier to write tooling for, and they would know, right? However, functional components have some drawbacks. They can't store state, they can't trigger re-renders, and they don't have lifecycle methods. And I know I just said that not having lifecycle methods was a positive, but it turns out that sometimes you just really need some code that runs after the component has rendered, and you can't do that with a plain functional component. So instead, we use hooks. But like I said, hooks are a bit confusing. They have these rules. You might have seen them. This is how they appear in the old version of the React docs. I haven't actually seen them in the new version of the React docs, but the new version of the docs are excellent, and I do highly recommend reading them. But in the old version of the docs, the rules are that you can only call hooks at the top level, and you can only call hooks from React functions. And who even knows what that means? You might also have seen the rules as a linter error. So the React hook useRef is called conditionally. React hooks must be called in the exact same order in every component render, which I think is a way more helpful phrasing of the rules. And in fact, I would suggest that we reword the rules to reflect that kind of phrasing better. So instead of saying only call hooks at the top level, we can say always call hooks in the same order. So this means that all of the hooks within a single component always have to be called in the same order every time that component renders. So the component can't return early and not call some of its hooks. You can't have hooks inside of if statements or while loops. When was the last time anybody wrote a while loop that wasn't in a job interview? And you can't have them in callbacks, right? Because callbacks can get called any old time. All right, the second rule then, instead of having only call hooks from React functions, I would change that to a hook belongs to an instance of a component. So any hook that you're calling, you need to be able to say which specific instance of a component that instance of that hook belongs to, right? So that means that you can only call hooks from inside components, or you can call them inside hooks that are called inside components, or you can call them from inside hooks that are called from a component, but you have to be able to trace it back to a component every time. Okay, so hopefully that clears up what hooks are a bit better. What the rules of hooks are a bit better, but it doesn't really explain why we have them. And the reason that we have these rules is because hooks store state in arrays inside closures. Now, if you're not familiar with closures, MDN describes a closure as the combination of a function bundled together or enclosed with references to its surrounding state, the lexical environment. So if you weren't familiar with closures a minute ago, you're probably still not really sure what a closure is. I'm not going to try and explain it anymore right now, but we are going to have quite a few examples of closures, and hopefully through seeing those, you'll get a better idea of sort of how they work. Okay, so the first hook that we're going to look at is useRef. useRef is most commonly used for grabbing a reference or maintaining a reference to an HTML element on the page. So say we have this form here where we have a number input and an input for adding some kind of object, and we want to submit the form. We can do this using useRef. So the code's going to look something like this, where we have our an item form component. It's going to have a count ref and a name ref, so one variable for each input that we care about. We're going to pass those refs into the ref prop of those input elements or components, which is going to give us access to the element itself. And then when we submit the form, we can get the value of each of those inputs using the ref.current prop. Okay, so how does this actually work? Well, here we have a fake implementation of React and our component. We've got React up the top here. One thing I just want to make super clear, we're going to have a few examples of this fake React implementation. It is fake. The entire point here is for you to build a mental model of what's going on under the hood. So in this example code, we've sort of gone for usefulness over accuracy, but it should be enough to actually help you build that mental model. All right, so when our component renders, the first thing that React is going to do is it's going to create a couple of variables. It's going to create an array called refs and an index that we're going to use to point to the array. Then we're going to render our component, and we're going to create our first ref variable by calling useRef. And when we call useRef, the first thing that we're going to do is we're going to check to see if there's anything in the first position of the refs array. So current index is 0, we're looking at the first position, we're seeing the first position in the refs array. Now we can do this because this ref function here is declared inside the scope of our fake React function. And anytime a function is declared in an inner scope that's inside an outer scope, the inner scope always has access to all of the variables that live in the outer scope. All right? This is what a closure is. It's an inner scope that has access to variables in an outer scope. Okay, so we can have a look in the first element of the refs array. There's nothing in there, so we're going to create an object which has a property called current and a value of the initial value, which is null. Then we're going to create a variable that points to that object. We're going to increment the current index, and we're going to return that object. When we return the object to the component, the mental model here isn't that we're giving the object back, it's that we're telling the component where to find the object. So it's kind of like a safety deposit box, like at a bank. So rather than giving the safety deposit box to our component, we're giving the component a key so that it can get into the safety deposit box. And it can look inside the box, it can see the value of current, it can change the value of current, but it can't change the box itself, right? That's always going to live inside the bank, or the refs array in this case. Okay, then we're going to do the same thing again for our second input element. We're going to create name ref, we're going to call useRef. Now this time, the current index is 1, so we're going to look in the second position in the refs array. And again, there's nothing in there, so we're going to create an object, again with the current property that is null. We're going to grab another variable that points to that object. We're going to increment current index again, and we're going to return that ref. Then we're going to declare our handle add item function, and we're going to return our JSX. When we return our JSX, we're going to pass CountRef and NameRef into the input components. And inside the input components, the current property is going to get updated to point to the actual input. And then after the component has finished rendering, we're going to run this cleanup function, which we're calling after, which is going to reset the current index back to 0. So the next time the component runs, the index will be 0 and we'll be starting at the start of the array again. Okay, so then at some point, our user is going to submit the form, which is going to call handle_add_item. And handle_add_item is an inner scope inside an outer scope, so it still has access to our nameref and countref variables. Now this is the tricky thing with closures. This inner scope, handle_add_item, still has access to the variables in the outer scope, add_item form, even though that scope has gone away, right? Add_item form has finished running, there's nothing going on there anymore, but handle_add_item still holds on to a reference to those variables with the values that they had at the time that handle_add_item was defined. All right, cool. So that is useRef. And the takeaway from that is, of course, that hooks store state in arrays inside closures. Okay, so what if we want to add some functionality to our form here? Instead of just passing the values into an alert, we actually want to display them on the screen. So if we say we want 4 apples, then we're going to have 4 apples. If we say we want 2 mushrooms, then we want to show 2 mushrooms. Now we can't do this with useRef. Useref can keep adding the items to a list somewhere, but it can't cause the component to re-render. So we would never see the apple and the mushroom on the screen, right? Until something else caused the component to re-render. So instead, we need another hook that can store state like useRef, but can also cause the component to re-render. And for that, we can use useState. Okay, so the code looks something like this. We're going to have a top-level component called inventory, which is going to manage the state. We're going to start with an empty array there. We're going to have our add_item function, which can update the state by calling the setInventory. We're going to pass that add_item function to our add_item form. And add_item form was the component that we created in the previous example. And we're going to pass the actual list of items to this item list component. And the implementation details of item lists are neither relevant nor interesting right now. So we want to have a look at how this useState works. All right, so when our inventory component is first called, React is once again going to create a couple of variables. So we're going to have our states array, which is going to store the stuff from our hook, our current index, which accesses the states array, and we're going to have this flag called run component. When our inventory component renders, first we're going to call useState and pass in that initial empty list. Now, inside useState, once again, we're going to check to see if there's anything in the first position of our states array, and there's not, so we're just going to pop that initial value in there. Then we need to do a bunch of stuff to figure out what we need to return in that tuple that useState returns. So first we need the value, and we can just do that by grabbing the value. And then we need to do, then we're going to create a new variable called setIndex, which has the same value as the current index. And we're going to create this setter function, which knows how to update the run component flag and the value of the state. And the reason that we need to create this setIndex variable is that you'll see our setter function there uses it inside it. So that means that the setter function is a closure which closes around the setIndex variable. If we'd just used current index directly, then on this next line, when we're going to increment current index, that would have also got incremented inside the closure because the closure is pointing to that exact same variable. And then we would have been pointing to the wrong position in our states array, right? So instead we create the setIndex variable. We have setter close over that setIndex variable. It never gets changed, so it's always pointing to the right position in the array. All right, and then we're going to return that value and the setter. We're going to declare our add_item function, and we're going to return our JSX. When we return our JSX, we're going to pass add_item into the onSubmit handler of our form. When we do that, React is going to create an onSubmit event listener, which is going to do a bunch of stuff, which we'll get into in a minute. All right, and after we've returned our JSX, we'll run our after function and reset current index back to 0. All right, and then sometime after that, our user is going to submit the form, which is going to cause the onSubmit listener to fire. The onSubmit listener is going to call the handler, and the handler is our addItem function, which we passed in earlier. Inside our addItem function, we're going to call the setInventory function, and the setInventory function is our setter function that we created inside useState. Now, inside the setter function, first we're going to check whether the value that is being passed in now is different to the value that's currently stored in the states array. And the reason we do that is if the values are the same, we don't need to re-render the component, so we could just do nothing. But in our case, they're different because the states array is empty, whereas the value array has an apple in it. So we're going to update the states array, and we're going to set this run component flag to true. Then we're going to pass control back to the handler, which is going to pass control back to the event listener. Inside the event listener, we're going to check the run component flag. And the reason we do that is that if we had multiple pieces of state being updated inside the handler, we don't want to rerun the component after every piece of state has been updated, right? We want to do all of the state updates as a batch and then only rerun the component if we updated anything, right? So if we updated one thing or multiple things, we want to rerun the component. But if we didn't update anything, we don't want to rerun the component, re-render the component. In our case, we did update a bit of state, so we need to rerun the component. So first we're going to set that flag back to false, and then we're going to render the component again. So once again, we'll call useState and grab our inventory and setInventory function. We'll declare our addItem function, and we'll return our JSX. Okay, so that's useState. It stores state in an array in a closure, and it re-renders the component whenever the state changes. All right, so we've got to a situation where we can display items on the page, but now we also want to let users be able to use the items. So we're going to do that via keyboard shortcuts. So if I press 1, I want to use an apple. If I press 5, I'm going to use a mushroom, and so on and so forth. Now we can do this with an event listener. We can't just use a key down handler on the component itself, because then it will only work if the component has focus. Instead, we need to add a key down handler to the top level, to the window. So we need to create a global event listener like this one here. So this event listener is going to listen for a key down event. It's going to calculate which key was pressed and which item that corresponds to. And then it's just going to decrement the count of that item. Once it's decremented the count, it's going to update the list of items by calling setItems. And this setItems is the same as the setInventory function that the inventory component had. When we call the setItems function, which is the setInventory function, that's a state setter, so it's going to cause the inventory component to re-render. And when the inventory component re-renders, it's going to cause our item list component to also re-render. This doesn't matter whether the prop has changed or not. When a parent component re-renders, the child always re-renders. But yeah, in our case, it has changed. So when the item list component re-renders, it's going to add another event listener. So now we've got 2 event listeners listening for key down events. So then the next time someone presses a key, both of the key down handlers are going to fire. They're both going to update their own copies of the items list, and they're both going to call setItems to update the list of items, which is going to cause the inventory component to re-render twice, which is going to cause the item list component to re-render twice, which is going to cause the item list component to add 2 more event listeners. And we are very quickly going to have a very large number of event listeners on the window object. I would demonstrate to you what that looks like, but it causes the browser to crash, and then my slides don't work. So we're not going to do that. The other issue here is that this event listener is a closure, right? And it's closing over the list of items. But every time we create a new event listener, we're creating a new closure, which is closing over a new copy of the list of items. So all of these event listeners are actually updating different copies of the list of items. And the end result is that you just end up with like weird stuff happening. So what we need instead is a hook that will allow us to add an event listener just once, and then to watch the event listener to wait until the closure goes stale, so it's no longer pointing to the most recent list of items, it's gone stale, and then to remove that old event listener and add a new event listener which closes over the new list of items. And the hook to do that is useEffect. So the code's going to look something like this. So useEffect is a function which takes two arguments. The first argument is the effect, right? It's the thing that we want to happen. In our case, it's adding this event listener. The second argument is a list of dependencies. And the list of dependencies is a list of variables that could cause the closure to go stale. So it's going to be variables that are used inside the closure, but are declared outside the closure, and that can change. I wouldn't worry too much about figuring out whether a variable can actually change or not. Instead, just ask the linter, and it will tell you exactly which variables need to go in that dependencies list. So the way that this works is that the first time the component renders, we run the effect, and then anytime anything in the dependencies list changes, that means our closure is stale, so we'll run the effect again. So that's going to solve the problem of having old versions of items list hanging around, but we're still going to end up with a lot of event listeners on the window. So that to fix that problem, we have one other piece here, which is that when we run the effect, optionally, we can return a cleanup function. And the cleanup function will get run before the effect gets run again. So what's going to happen here is that the component will run, we'll add the event listener. When the list of items changes, we'll run the cleanup function and remove the event listener, and then we'll run the effect again to add the event listener again. All right, so once again, the three pieces we had here are the effect, which is what we want to happen, the dependencies, which is how we deal with those stale closures, and the cleanup function, which is called before the effect is rerun. Okay, so how does this work? Well, once again, we have an array which has our hook stuff in it. It's called effects this time, and we have an index that points to the array. When our component renders, it gets passed in the list of items and the set items function, and we call useEffect. And we're going to pass into useEffect two things: the callback, which is the effect, the function that adds the event listener, and the dependencies, which is the items list and the set items function. So we'll just pop those in line. So just like with our other hooks, the first thing we're going to do is check to see if there's anything in the first position in the effects array. And there's not, so we're going to create an object with a property for the callback function and one for the dependencies. It's a little bit hard to see there, but there is actually a line going from the CB property, the callback, to the little event listener with a purple plus on it. Cool. So then we're just going to increment current index and pass control back to the component. And the component is going to render its JSX, and then it's going to run the after function. So the useEffect hook runs asynchronously. All of the interesting stuff happens after the component has rendered. Okay, so inside our after function, the first thing we're going to do is check to see if we need to run any cleanup functions. So we're going to iterate through all of our effects. In our case, there's only one, so it won't take too long. And we're going to check if it needs a cleanup. So we're going to check first to see if the dependencies have changed. To do that, we're going to check to see if our effect has a property called previous dependencies. We don't, because this is the first time the component's run, so we're just immediately going to return false. The dependencies haven't changed. And then we're going to check to see if the component is unmounting. So a component is unmounting if it's not going to be rendered anymore, right? It's being removed from the DOM. You'll just have to take my word for it that our component is not unmounting. Okay, so now our component doesn't need cleanup, so we can skip that. And we can just move straight on to actually running the effects. So once again, we're going to iterate through all of our effects. And this time we're going to check a couple of things. So first we're going to check if the effect has a dependencies array. And the reason for this is that the dependencies array is actually optional. If we don't pass one in, then the component will just run the effect every time it renders. This might seem a little bit silly, like why didn't we just put the code inside the component then? Why use a use effect? And the answer is that sometimes you need code to run after the component has rendered. So for instance, if our code needed to measure how big something was on the screen, we can't do that until after the thing has been rendered to the screen. So we have to wait for the component to render and then do the measurement, which means we need to do the measurement inside a use effect. The second thing that we want to check is if the component has a previous dependencies array. And the reason that we check for this is that effects are guaranteed to run at least once. So if this is the first time that the component is rendering, it's not going to have a previous dependencies array. So that means that the effect needs to run. So in our case, that's true. So we can step inside this if block. All right, so the first thing we're going to do is update our effect here to have a previous dependencies array. We're going to create that previous dependencies, and it's just going to point to the same thing that the dependencies is pointing to now. Then we're going to run our callback, and our callback is going to add this purple flavored event listener, and it's going to return our cleanup function. And our cleanup function is also going to get stored in the effect, and our cleanup function there is a function that knows how to remove that purple colored event listener. Okay, then we don't need the other two anymore, and we can reset current index, and we're done. Okay, so then at some point, the user is going to use an item, right? They're going to hit that key down, and our key down is a closure, which closes over our set items function. So it knows how to update set items, which is going to cause the parent component to re-render, which is going to cause our item list component to re-render with a new list of items, which doesn't have an apple anymore. So when our component re-renders, we're going to call use effect. We're going to pass in our new callback function because our new effect is going to close over a new event listener, which is closing over the new list of dependencies. Where is that code gone? Okay. And we've got our new dependencies array, which doesn't have the apple in the list. All right, so this time there is something in the first position of the effects array. So we're going to jump into the else block, and we're just going to update the existing object. So we're going to keep the properties that are already there, the cleanup and previous dependencies. We're going to add our new callback, which is the function that adds the blue event listener. And we're going to add a new dependencies array, which is the new array that contains the array that doesn't have an apple. And then we're going to increment current index and pass control back to the component. The component's going to run its JSX, render its JSX, and then then we're going to call our after function. So again, we need to check to see if we need to do any cleanup. We're going to iterate through all of our effects. We're going to check to see if the dependencies have changed or the component is unmounting. So this time, when we check if the dependencies have changed, we do have a previous dependencies array, so we can't take the shortcut. Instead, we've got to run the whole check. And this check is going to go through every element in the dependencies array and have a look at the element in the same index of the previous dependencies array and check to see if those two items are the same. In our case, they're not, because the first element of the dependencies array only is an array with 2 objects and not the array with 3 objects that's in the previous dependencies array. So this is going to return true. All right, so needs cleanup, dependencies has changed is true. That means needs cleanup is true. So needs cleanup is true, and we have an effect cleanup function. We have a cleanup function because cleanup functions are optional, but in this case, we've got one, so we're going to run it. And our cleanup function is going to remove the purple event listener. Then we're going to run our effects. So once again, we're going to check, do we have a dependencies array? Yes, so that first condition is false. Do we have a previous dependencies array? Yes, so the second condition is also false. Have the dependencies changed? Yes, we just checked that, we know that returns true. So we are going to update our effect. Our previous dependencies is going to point to the new dependencies. So we don't need the old one anymore. We're going to run the callback, which is going to add the new blue event listener. And we're going to store the cleanup function, which knows how to remove the blue event listener. Cool. And then we're going to reset current index back to 0. And that's it. That's useEffect. So a couple of things you might have noted about the dependencies arrays. So first of all, the effects always run at least once. Secondly, if there's no dependencies array, it will run on every render. And thirdly, something that wasn't perhaps as obvious from the code, but if you pass in an empty dependencies array, it will run exactly once. And that's because effects are guaranteed to run at least once. And if there's nothing in the array, it can never change. So it's only going to run exactly once. Okay, so useEffect is useful for a bunch of things. We can use it for native event handlers, like we just did in this example. We can use it for other native APIs, like set timeout, set interval, and request animation frame. We can use it for making HTTP calls, either with the native APIs or with the library. And we can use it for interacting with third-party libraries in general when those third-party libraries don't understand how React works. One thing about useEffect, though, is that effects are an escape hatch from the React paradigm. They're there for situations where you're dealing with something that doesn't understand how React works. Something that you absolutely shouldn't be using effects for is watching for changes in your props and reacting to changes in your props. You don't need a mechanism for reacting to changes in props because that's exactly what React is. That's why it's called React. What am I talking about? Okay, so imagine we want to add some functionality here to be able to sort these items. So we can sort them by name, or we can sort them by how many you have. To do that, we might be tempted to write some code like this. So we might be tempted to add a bit of state that holds the sorted list of items, and then to add an effect which watches to see if the list of items or the sort key changes and update the state with the new list of sorted items. And this is absolutely not how you should write this. In fact, the React docs say don't use effects to transform data. If you can calculate some information from the component's props or its existing state variables during rendering, you should not put that information into that component's state. So what should we do instead? We should just calculate the item every time the component renders. So here we can calculate the list of sorted items by the items list that's passed in as props and the sort key that we've got stored in state there. So we can just recalculate the sorted items every time the component renders. Okay, so at this point, someone's going to ask, what if my calculation is really expensive? What if there's a million things in my list, and if I have to resort them every time the component renders, it's going to slow things down, and it's going to be a really terrible user experience? Well, the answer is there's a hook for that, and that hook is useMemo. So useMemo memoizes a value, which means that it stores a value and it only recalculates it if it's actually going to change. So if we wanted to memoize our sorted items here, it would look like this. So once again, useMemo is a function which takes 2 arguments. The first argument is a function that does the calculation to figure out our value. In this case, it's a function that sorts the list of items. The second argument is a list of dependencies. So it's a list of the variables that can cause our calculator function closure to go stale. And anytime anything in the dependencies list state, the next time the component renders, it's going to recalculate the value, right? So anytime our items change, we'll get a new list of sorted items. Anytime the sort by changes, we'll get a new list of sorted items. I'm not going to run through the actual implementation of this one, but you probably won't be surprised to learn that it stores state in an array inside a closure. All right, so one last bit of functionality we want to add here is it turns out that our users hate the keyboard shortcuts. Instead, they want to be able to use an item just by clicking on it. I'm like, that's fine, that's easy, we can implement that. It's going to look something like this. Inside our item list function, we're just going to add a button inside our list item with an on-click handler that knows how to use the item. The code that goes inside this on-click handler is actually identical to the code that we used inside our keydown handler. This code is potentially a bit complicated, and we don't really want to duplicate it in the two places. So we're going to extract it out into its own function, which we're going to call consume item. You might have been tempted to call this use item, but if you do that, the linter will get real mad because functions that start with use have to be hooks, and this is not a hook. Okay, so we've got our function called consume item, and we can pass that to our onClick handler, and that's all fine and great. And we can also use it inside our effect. Except if we do this, the linter is going to get mad, and it's going to say that we need to put the consume item into the dependencies array. Because it's a variable that's declared outside of the closure, and it can change, so it's a dependency. If we do this though, the linter is still going to be mad, and it's going to say that the consume item function makes the dependencies of useEffect hook change on every render. And the reason for this is because we have declared the consume item function inside the component. Each time the component renders, we're declaring that function anew, right? It's going to be a new copy of that function. So even though it's always going to have the same functionality, it's going to do the same thing, it's going to live in a different place in memory, and that means that useEffect is going to consider it a different item. So that means the dependencies array has changed, and we're going to re-render the effect. In this particular case, that's not the end of the world. It's not going to break anything, but there are definitely situations where it can break things, or it will break things. And even here, like, it's a bit of a waste. Like, we don't need to tear down that event listener and add a new one every time the component renders, so it would be better if we fixed this. Also, I just don't want the linter to be mad at me. I want it to be happy. So what we need is a hook that calculates a value and then stores it, and only updates the value if the calculation needs to change, right? So we need to memorize this function. We can do that because we have this hook, use memo. It just looks like this. We can pass in a function that returns our function, and the list of dependencies is going to be items and set items. The thing is, though, this is a little bit ugly, right? This whole situation where we've got an arrow function returning an arrow function, it's kind of hard to read. I don't love it. And it turns out that the React team agree with me because they created an entire hook whose sole purpose is for me not to have to write arrow functions returning arrow functions. I mean, it probably wasn't just for me, but this whole situation in general. This hook is called useCallback. So useCallback, it's just use memo, but for functions. So instead of memorizing our function like this, we can callbackize it like this. And that's it. The only difference is that instead of passing in a function that returns our function, instead we just pass in our function. Right, so that is everything I wanted to cover today. What have we learnt? Hooks store state in arrays and closures. And it's perhaps worth mentioning that once we do this, our functional components aren't actually pure functions anymore, so we're losing one of the advantages that we had from them. But we've all decided that that's a trade-off we're willing to make. Well, probably you and I didn't decide that, but someone decided it on our behalf. So that's how we roll now. useref doesn't do anything else. It just stores state in arrays, enclosures. It's got no special powers. useState triggers re-renders whenever the state that it's storing changes. useEffect is an escape hatch and should only be used in situations where the React lifecycle isn't going to work for some reason. And useMemo and useCallback are the same thing, and they memorize things. If you enjoyed this topic, something that interests you, I would highly recommend having a look at Swix's Getting Closure on React Hooks. He has both a blog post and a conference talk recording thing on YouTube. And he concentrates on sort of different aspects of the hooks and how like the state stuff works. So I would definitely recommend having a look at that. He's also clearly better at naming talks than I am. Also, Advanced React by Nadia Makarovich can be helpful with understanding sort of, I guess, advanced topics about how components re-render and why they re-render. Dan Abramov's just JavaScript. It's kind of the opposite side of that, where it is a very intro level text on JavaScript, but it can really help with building mental models about things that you probably use every day but perhaps only have a fuzzy understanding of. And finally, if you need a Legend of Zelda based font for your project, this one is Omni Jakala's Hylia Serif. You can get me on LinkedIn. The slides, as mentioned, are at hooks.ez.codes, and I'm on Twitter, I guess, at Aaron J. Zimmer. Thank you.